Let's do this example. I have a function f, and I'd like to find the zeros of f and also find the maximum and minimum of f. You'll note that f is in ax squared plus bx plus c form. To find the zeros of f, I'm going to make use of the fact that I can factor this. First, I'll factor out a 2 because that leading coefficient. Now I'm going to factor the quadratic inside the parentheses. With it factored now, I know the zeros. They're readily apparent because each factor set equal to 0, solved for x, gives me the location. Okay. So if you can't factor and solve, remember that the quadratic formula is also available. Now for the second half of the problem, let's find the maximum or minimum of f. We need to think about what that means for a particular function. I'm going to make a really quick sketch of this function to help understand. I know that I've got 2 zeros as well as what else do I know? I know that it's an upward opening parabola because the leading coefficient is positive. So an upward opening parabola with zeros at 1 and 2. We've got something going on like this. This function's going to have a minimum because it's an upward opening parabola. Also, if my sketch is to be trusted, I think the minimum is going to occur in the 4th quadrant. Now let's actually solve for it, the minimum of this function. How am I going to go about that? Well, I happen to already have the zeros, so I know that the minimum will occur halfway between the zeros. Halfway between 1 and 2. Oh, geez, I'm so sorry. Looking at my work here, halfway between 1 and 2 is not 1/2, it's 3/2. All right, so I know the x-coordinate of my vertex, it's at 3/2. I don't know what the y-coordinate is, so I'm going to substitute 3/2 into the original function and solve for y. Okay, next step, let's continue solving. This means that the minimum of this function is at the coordinate 3/2, -1/2. That's the minimum point of the function, and then also zeros. Hope that's been insightful.